Welcome to the course structure analysis. Myself, Dr.S.Pachaiappan, Assistant Professor in the Department of Civil Engineering, Aditya University. So, in second lecture, we are going to discuss about the different types of beams. So, particularly in structure analysis, we are going to only analyze two different types of structures. One is beams, structural element beam, and then portal frames. And in this course, we are not going to analyze the entire building, either a steel structure or concrete structure. We are not going to analyze. That is a software package which will be discussed in the STAD Pro or ETABS. Here we are going to discuss about the basic things, that is the analysis of beams and analysis of portal frames subjected to loading. So, coming to the different types of beams, beams are categorized based on different things. One is based on support condition, and then based on the construction materials, based on cross section of the shape, based on the geometry, and based on equilibrium condition, and then also the method of constructions. Okay, but in this we are going to mostly give the important and discuss about the beams based on various support conditions. Okay, anyhow, orally we will discuss the all types of things. First of all, based on the support condition, you know that we will be having the hinged support, we will be having the fixed support, and pinned support, and horizontally guided roller, vertically guided roller, all those things are there, we will discuss. Okay. Then based on the construction materials, what type of the beam is there, what type of material is used to fabricate this beam. So that is a material classification. For example, concrete beams are there, steel beams are there, beams are made of timber, beams are made of composite materials, beams are made of functionally graded materials. So, what type of material we are using based on our requirements. So, that is a material classification, and based on the cross section shape, there is a terminology called prismatic section. Prismatic section means you can able to see this pen, consider this is a beam, and from the starting point to the ending point, I can able to say this beam is prismatic. The reason is it is having the uniform cross section throughout the length, uniform cross section throughout the length. That is why it is called as a prismatic beam. So, what are the beams comes under on the cross section shape? Beams generally going to have a shape of rectangular, that is because of the moment of inertia things. So, we going to have the rectangular beams. If it is a column, it may be the rectangle or it may be circular. So, depending upon the shape, which shape it is having, we might sometimes we used to have the diamond cross section columns, and if it is a steel section, we are going to have the different cross section of the beams, I section, T section, channel section, H section, all these are the cross section. So, similarly the geometry also. Geometry particularly depends upon the moment of inertia. And then based on the equilibrium condition, we discussed in the first lecture, three equilibrium conditions are there. Based on that, we can able to solve the unknown forces. And then method of construction also we can able to classify whether it is a prefabricated construction, pre-tension, post-tension, conventional concrete structure, or it is a steel structure. Based on many things we can able to discuss. But if you see the first one, based on support condition, we are going to discuss here. Remaining things are related to construction materials. So, we are not going to discuss here. The first thing we are going to discuss, that is beams support conditions. Okay. So, before going to support conditions, let us discuss why it is important. Because if you have any structure, in generally first lecture I told, any structure, we never want that structure should move. Okay. The structure should be stable under the action of any type of loads. So, if you provide some roller support, then the structure can move here and there. But still it is having the applications where and all we are having the roller supports, For example, in the earthquake resistant design of structure, we never want the structure is completely anchored on the earth. So, it is going to transfer the ground acceleration to the structure. Finally, the structure going to deform a lot, okay, deteriorate a lot. We never want that. So, we used to do the base isolation by using different types of mechanism, which is nothing but we kept the structure on the roller support, okay. So, it is based on the application, but in generally, we never want the structure move, okay. So, simply supported means I have a beam, please see the board, I have a beam. Simply supported means I should have one hinged support and then another one is a roller support. Let us say this is having the span L. So, this arrangement is called as a simply supported beam. So, before that we will discuss about the support condition for better understanding. This kind of symbol is represents the hinged support. So, this is the hinged support. Then if at all we have this kind of a symbol, then it is called as a fixed support. And sorry, we have a hinged support. At the bottom we have the roller. This is called as a roller support, but I am going to write horizontally guided roller. So, this is the horizontally guided roller, and one more I am going to draw. This is called as a vertically guided roller. So, in which direction the support is provided? So, horizontally guided roller, and this is a vertically guided roller. So, maximum we supposed to have these support conditions only. With this we will draw what are the different types of beams. So, I told if it is a simply supported, then we supposed to have the one hinged support, another one is a roller support. You might ask, sir, in the beginning of the lecture you told that any structure should not move. In that case, why we added the roller support here? It is very simple to understand. Any material, it is going to elongate and then it is going to contract based on the temperature condition. Any material going to subjected to the contraction and then elongation, because this material subjected to the coefficient of thermal expansion. Now you imagine this joint is pinned and this joint also hinged or pinned. It is not allowing the beam to elongate axial direction. It will be subjected to lot of stresses. That stress is going to create the internal forces, which is going to cause the material deteriorations. So, we allow the beam to move in the right hand side direction if it is subjected to the elevated temperature. Okay. So, generally in beams we neglect the axial forces because that is significantly very less compared to the bending moment and shear force. So, that is the reason we are neglecting. Then discuss what is meant by the fixed beam. So, this is the simply supported beam, simply supported beam. Let us draw the fixed beam. So, fixed beam means both the ends are fixed. It is not going to allow the rotation, it is not going to allow the axial deformation. So, both both axial deformation and then rotation, it's not going to allow. It is completely held in position which restricts the rotation. So this is called as a fixed beam. And also I would like to discuss, let's give some names for this A, B. So here also let's give A, B. Now support A, the moment at the support A is 0 because it's a simply supported. Moment at B is also is 0 because it's simply supported. But in fixed beam, MA is not is equal to 0 and also support B, the moment is not is equal to 0. Okay. Let's say some examples. Simply supported beams generally used in bridges. Okay. On the top of that, the girder is placed. Where the fixed beam is used, whatever the structure day to day we are using, for example, our own houses, our institutional buildings, you observe the columns and beam joint, it is a fixed connection. It's not a pinned connection, it's not a simply supported connection, it's a fixed beams. Now let's discuss about the continuous beams. Let's discuss about the continuous beams. There is a criteria for continuous beams. For example, I have a support, simply supported condition. I have another support. Let's consider I have another support. Now, what is the criteria? Let's say this is L1 and this is L2. Any beams having more than 2 supports, any beams, I am writing, any beams having more than 2 supports, then that is a continuous beam. In other words, are any beams having 2 spans or more than 1 span, more than 1 span, then it is also called as a continuous beam. So it's very simple. When the support is more than 2, continuous beam. When the span is more than 2, is a continuous beam. Okay. So this is a continuous beam. Where is the application of the continuous beam? Continuous beams you can able to see the bridges. Okay. So there will be the simply supported beams which is continuous in nature, and then on the top of that we are going to have the girder. Now one might ask, sir, why all the bridges are made simply supported continuous beam? That is a great question actually. So why? The reason is, on the top of the bridge we are going to have the moving vehicles. The moving vehicles is slightly always going to pull the deck slab towards the direction it is moving. If it is completely constrained and fixed, it's going to create the loss of stresses. In order to avoid that stresses and the damage to the bridge, we are modeling it to the simply supported. So there will be the bearing, which is a viscoelastic material between the bridge deck and then the piers, the columns, so that the beam is slightly in the bridges, slightly allowed to move in the forward and backward direction to adjust its position. That's why it is a simply supported conditions provided in the bridges. Okay. So we are not going to restrict the movement of the beams or the slab in the bridges. Then another application is during the earthquake. If any span particularly fails, it's not going to affect the adjacent spans. If it is a fixed support condition, one span fails, it's going to pull the another span, it is going to create the progressive collapse. Okay. So in order to avoid those things, we are going for a continuous beam, simply supported continuous beam for the bridges. And let's discuss about the another category is called as a cantilever beam. This is a very important type of beam. So the cantilever beam means we have a beam which is having the support condition. Cantilever beam, one end is fixed, one end is fixed and other end is free. One end is fixed, other end is free. You can see the support A is fixed and at support B we have the free end. So this is called as a cantilever beam. Where and all the cantilever beams are used? The cantilever beams are used in the lintel beams. The cantilever beams are used in the portico slab. The cantilever beams are used in the sunshades. So on the top of above the window, we can able to see always a slab is projecting outside, which is going to avoid the rainwater seeping into the window. That projected area is nothing but the cantilever slab or the cantilever beam. Okay, so the criteria is very simple. One end is fixed, other end is free. That is called as a cantilever beam. In this, another type is there, that is called as a propped cantilever beam. That is a propped cantilever beam. Prop means additional support. Either it's a support, in some cases it is a additional support. Where I am going to provide the support? I am going to provide the support to my cantilever beam. So this is a cantilever beam A and I am going to provide the one more support at the free end. This is called as a additional support. This additional support is called as a prop. That one may ask, the prop will be given only on the free end? No. It's based on our requirement and then application. The prop may be given anywhere along across the length of the beam. That is called as a prop. Okay. So there are two different types of beams. One is a normal cantilever beam, another one is a propped cantilever beam. So if you apply the equilibrium equations also, the normal cantilever beam is statically a determinate structure and the propped cantilever is statically indeterminate structure. Those things we are going to discuss in the next lecture. So I am not going to discuss here. So here we are going to discuss only the different types of beams. So we have seen the cantilever beam and then another beam is called as a overhanging beam. Overhanging beam. So what is meant by overhanging beam? It is a cantilever beam. It is a cantilever beam. Instead of providing the support at the free end, I am going to provide the support somewhere in between the beam. Let's say the overall span is L and this span is L1 and this is L2. Now here is L2 represents the overhang. The L2 represents the overhang. Outside projected region is called as a overhanging beam. Okay, so where and all it is used? In a multi-story buildings, for architectural aspects, some of the floor is projected outside. Okay, in the suspension bridges, two deck slabs will be there and the deck slab is projected outside. There and all we can able to see the overhanging portions. And also another thing, if you go to the railway station, on the top of that, there will be the provision for carrying the electrical wire, which is giving the electricity to the train to the pantographs. So the wire which is the electrical wire carried by the post, those posts are also the overhanging or cantilever projection. So in this lecture we have seen different types of support conditions. We have seen different types of beams. Okay, we just saw what are the different support conditions are there, different types of beams are there. Okay, and then in next lecture we are going to discuss about why the structure is statically determinate, statically indeterminate, why the structure is kinematically determinate and indeterminate. Okay, in this lecture we never discussed about the stress because stress is not considered as a beam. Okay, thanks for watching this lecture. Thank you.